Okay, where in the world have you been, Magnus?
It's complicated.
You have passed? Come back if you're in flex and take the quiz. Okay, so I put some four-sided shapes up here on the board. Hopefully one of those is the answer you put down. He wasn't specific, so any four-sided shape, but there's your little family of quadrilaterals. Remember that you learned in geometry? No, but that's awesome. Good for you. Now, we got two things I want to do. The first thing is on the extra practice sheet that's part of your homework that I gave you yesterday, we have the last problem, number 5, is different. And it's different because the rest of the problems, well, the first one says complete the square. Then the rest of them have the radicals like we talked about yesterday where we square both sides. Remember? This one doesn't. So we're not squaring here. There's no radical to get rid of. What we're going to do is do what we always do with polynomial equations. And up to this point, we've only talked about quadratics. But what do we do if we have an x squared equation? What do we do with it? We get it equal to 0. So we're going to first of all get this thing equal to 0. Okay? When you are solving an equation that has powers in it, get it set equal to 0. Do not use the quadratic formula. This is not a quadratic, right? Do not complete the square. This is not a square. Well, wait a minute. What is my only other option then? If I can't use the formula and I can't complete the square, because it's not a square problem, then the only option I have left is to factor it. So let's look at it. What kind of factoring can I do? Take an x out. GCF. Take out an x. And then, bing, 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 bing. Yes, this should pop out at you. You have seen this before. X squared minus 4 is called the difference of squares. And we need to be able to factor it. How does the difference of squares factor? X minus 2, x plus 2? Listen, if you've forgotten that, guys, you got to remember. A squared minus b squared. A plus b, a minus b. Right? Make a note of that. Put a star by it. You need to know that. Now, once we have it all factored, remember what you do? You set each one of these equal to 0. There's going to be 3 of them because it's a cube equation. Cube equations have 3 answers. Squared equations have 2 answers. So we set them all equal to 0. It looks like x equals 0. So one of my answers is 0. X equals 2. Can I skip ahead without writing it down? You see how x equals 2 here? And x equals negative 2. So there are the answers to the question. Okay? Now in chapter, I think it's 2, we're going to spend a lot more time with these guys and talk about ones that maybe don't factor quite so nicely. But for now, that's how you handle it. Okay? All right. So that's that one. That's that sheet. Okay. Now we're back in our notes. And yesterday we started talking about the imaginary numbers, right? Are we ready for number 1D in P6? Take a look at your notes and see.
That's where we are.
We're on the back of page 5.
Yep.
And we're ready for 1D in section P6.
Yep.
So we had yesterday, we did A, which was just an adding. We collected like terms. B was a subtraction. We said it's easy. The only thing you have to worry about is distributing the negative. C was a FOIL. Remember that?
Yep.
And the thing we have to remember there is when we have an I squared is -1. Now we're ready for the division problem. Does anyone remember anything about this?
You multiply by the converse.
Anybody see it? You see it?
Multiply by the converse. Yeah.
Oh, here it is. Yep, thank you. What do? I heard somebody say it, I think.
Multiply by the converse.
Multiply by the
Converse. Inverse.
conjugate.
Conjugate.
It's called the conjugate.
I knew what it was. I meant to say that.
So the conjugate, if we have a plus bi, the conjugate is a minus bi. So we're going to take this problem and we are going to multiply the top and the bottom by the conjugate of the bottom. So what is the conjugate of 6 minus I? 6 plus I. So we multiply top and bottom by the conjugate of the bottom. Now, maybe you've forgotten why that is, why we do that. Well, you're going to see in a minute. Hold on to your hats. Let's FOIL the bottom. FOIL the bottom. So, first, outside, inside, lasts. What do you notice? These guys cancel, right?
Yep.
And what do we know about I squared? I squared is -1, so negative I squared will be +1. So the bottom is just 37?
Yep.
That's why we did that. Because there's a rule that says you can't have radicals in the bottom of a fraction. And you're looking at that and saying, well, Miss Ford, we didn't have a radical. Yes, we did. Because what's I? The square root of -1. You are not allowed to have i's or radicals of any kind in your denominator. So to get rid of that, we just multiply by the conjugate. Now, we still have stuff on the top, so let's FOIL the top. First, outsides, insides, lasts. These add, right? So we have 23i. Now tell me about positive 3i squared.
I squared. It should be -3.
3i squared turns into something. Yes, it does. What does it turn into?
-3.
-3. Remember, I squared is -1. So 3i squared would be -3. So if that's a -3, I've got, what, 27 plus 23i? And that's the answer to the question. These can reduce, this one doesn't, but if we had done the problem and ended up with something like this, that would reduce because all of these numbers, and it has to be all of them, all of those numbers are divisible by 3. So if you got something like this, you would be expected to reduce it. Now, the 2 and the 4 reduce, but don't do it, because the only way you can simplify is if you can do it in all 3 places. Okay? So don't get cancel happy. You gotta be able to cancel out of all 3 places. Got it? All right, what about E? What's going on with problem E? The square root of -81. Oh, getting carried away here. First thing you recognize is you got the square root of a negative, so that's going to have an I in it, right?
Yep.
And the square root of 81 is 9. So your answer is just 9i.
Is it not plus or minus 9?
Okay, that is a very good point, but we got to be clear on this. When the radical is already present in the problem, it takes whatever sign is there. So there's no sign out here in front, so it stays positive. If we had this, then it would be negative 9i.
Okay.
When we do the plus or minus, Jalen, it's when we have a problem like this. There is no radical in that problem, but I'm going to put one in. When I put the radical in, then I have to do plus or
So when it's
minus.
there, it's
When it's there, well, it's always whatever's in front of it,
Okay.
so it could be negative to start
Alright.
with. This one wasn't.
Thank you.
All right, F always causes us problems because we're tempted to just multiply these two together, and we can't. If you have the square root of a negative, the first thing you have to do is take care of the I. So this is going to become what? What does the square root of negative 4? That becomes 2i. What does this one become? 3i. Now I'm going to multiply them, and I get 6i squared. But wait a minute, I squared is negative 1, so the answer to the problem is negative 6. Whenever you have the square root of a negative, please take care of the I first. All right, now this next problem is going to drive you absolutely crazy, and it shouldn't. This is about the easiest thing that there ever could be, truly. These two numbers are equal to each other. Your job is to figure out what x and y are. There's no work to be done. It's right there staring at you. What does x have to be? 3. And what does y have to be? No, y is just 2. If these two numbers are equal, the part without the i's have to be equal. So the 3 and the x have to be the same thing. And the part with the i's have to be equal. So 2 has to be y. It's so simple. Now I tried to get tricky on the next one, but I didn't get too tricky for you. The part without any i's have to be equal. So on this side, this is the part without the I, right?
Yeah.
And on this side, this is the part without the I?
Yep.
So x has to be 3. Now, on this side, this is hooked to the I. On this side, this is hooked to the I. So negative y has to be 7, which means y has to be negative 7. When two complex numbers, that is numbers with i's in them, when two complex numbers are equal to each other, the part with the i's has to be equal, and the part without the i's has to be equal. It's that easy. Whatever is hooked to the I, match them up. Whatever is not hooked to the I, match them up. All right, now I got a few little review problems in here. So what I'd like to do is have a volunteer or a pair of volunteers come up and do 3A on the board. This is just like your quiz, only there's no directions. So what are your choices for 3A? You could try to factor, quadratic formula, complete the square. I couldn't care less. Come up and give it a whirl. Do I have a volunteer? And the same with B. Do I have a volunteer? You may come with a friend or you may come on your own.
I was just going all the way down to
we're starting with these two. If you are not at the board, you are doing this at your seats. Just two right now, but we're going to do the next two. You can do one of those. Whatever you want. As long as it's not cheating. We're just doing A and B right now. If you get those done and want to work ahead, that's fine. But everybody who's back there giggling should be working on these. I know, it makes me happy too.
You can solve this however you want.
However you want. A does not factor though, right? So factoring is not an option for A. And it looks like they're both using the quadratic formula, which is fine. It will always work.
Mrs. Boyd, is homework still due on the date you set?
Well, I may have to change that. I think I'm probably going to have to change it because we still have section 7 to go. In fact, I'll just change it now. I'll just say it's going to be due Monday. So you have another weekend. You need to, since these are simplifiable, you need to simplify. So 9 plus 5.
I feel like that really shouldn't be there. Yeah. I feel like I should be on like a shelf somewhere. Like one of those shelves. But, that's kind of a big deal.
Okay, let's take a look at the answers the guys got and see what you think. -2 plus or minus root 2, perfect. This is the right answer. Now, did you guys who used the quadratic formula like he did, it's kind of small here, what he got was this. If you got that, did you recognize that these all reduced by 2? So that's what he did, and that's how he got this as his answer.
No, you're good.
Okay, so everybody okay with these? Now, this one, he did everything exactly the same, but he had a perfect square. So his answer didn't turn out looking like that. He had 9 plus or minus 5 over 4. He has to reduce that. 9 plus 5 is 14 over 4, so 7 halves. And 9 minus 5, 4 over 4, which is 1. So there are his answers. When you get that kind of answers, no radicals, when you get rational numbers as your answer, no radicals, that means a factor. So if you notice, this one does factor, so some of you may have factored it. This one doesn't.
Could you go over completing the square, please?
Okay, real quickly, Agnes. You need to get to school on time. I'm going to add 4 to both sides because half of 4 is 2 and 2 squared is 4. So this is x plus 2 squared equals 2. I take the square root of both sides, and sure enough, -2 plus or minus root 2. Same answer. Okay, so those are review. Now we got two more reviews. Number 4, A and B are both review problems. So I need volunteers to come up and do
I got B.
A and B, 4A and B. So 4A, we are foiling. And 4B,
Conjugating.
we're conjugating, I guess, yeah. Sounds like what we do in our foreign language class, but. All right, so everybody should be trying these. Come on your own. Let's see what we come up with. He got over here kind of small. He got 26 minus 13i. He actually has it written the other order. The order doesn't matter. Normally we put the real number first, but it's fine. And that's what I got when I foiled. We got a negative 14i squared, which is a positive 14. So that's how 14 and 12, that's how we got the 26. Anybody have a question about that? And Jalen got 1 plus 31i over 13. And that's what I got too. So he multiplied top and bottom by 3 plus 2i. Did a bunch of foiling. Remember, when you get this 14i squared, that's a negative 14. So that's how we got 1. 15 minus 14. Any question about that? Good? Okay with foiling? Every I squared becomes a negative 1. Alright. Then, yesterday I had the privilege of observing an Algebra 2 class, and guess what they were doing?
Factoring.
No. They were doing absolute value inequalities, which is what the very next problem is. It's an absolute value inequality. Now, we're going to talk about doing this problem the way you did it last year, and that's fine. But we're also going to look at this problem from a little bit different standpoint. And as with all things, as long as you're not cheating, I couldn't care less how you do it. So if you want to go back and do it the way you learned it in algebra, that's fine. I won't be doing it that way in class. I will be doing it using a calculus strategy, when you'll encounter things that look like this in your calculus class, and they will be approached from a more calculus standpoint, which I think is easier, but it's new to you, and you may want to fall back on your old stuff, and I'm fine with that. Totally fine. So here, what am I talking about with this new strategy? Well, I want you to think about this. If I said to you, here's my number line, and here's the number 6, and here's the number 15. If I said to you, how far apart are those two numbers?
9.
You would say 9. And how did you get 9?
15 minus 6.
You subtracted, right? And actually, when you subtracted, you took the absolute value, because you could have subtracted 6 minus 15 to get the distance, right? So when we see something like this, when we see an absolute value and a difference, a subtraction problem in there, what we're really doing is talking about the distance between those two things. So this means the distance between 8 and 2. So what does this mean? This means the distance between some number and 2. So here's my number line. Here is the number 2. This says that the distance between some number and 2 is more than 3. Now wait a minute. Let's put that some number right here. If that distance has to be 3, where is this number? If that distance has to be 3, this number would be 5. Aren't those 3 apart? And what if I put the number back here, though? If these have to be 3 apart, this would be -1. So those two numbers are the boundaries. These are exactly 3 units apart. This says the distance between something and 2. Here's 2. The something has to be more than 3 units away. Wait a minute, this is exactly 3 units away. If I have to be more than 3 units away, where would I be? Out here? All those numbers are more than 3 away? Or back here? All those numbers are more than 3 away? So my answer is everything bigger than 5 or everything less than -1. If I pick any number out here, it's going to be more than 3 units away from 2. Right? Oh, you're looking at that thinking, what in the heck? That is so confusing. Oh my goodness. No, let's try a couple more. I think you'll get it. So then when you do your limits in calculus class, you'll be all set. Let's look at this one. Yes, you're all aiming to get calculus. It's a good class. You'll enjoy it. All right. A couple things different about this one. What do you notice about it?
Is it a greater than or less than or equal to 6?
Well, there's an or equal to, right?
And this one.
Do you have any idea what an or equal to might do in terms of my number line? Color in the dots? So I'm not going to worry about the or equal to. I'm a little worried about this. That's a plus. And didn't we say when we looked at these kinds of problems, the distance has to be a subtraction problem? Wait a minute. I wonder if I could rewrite this as a subtraction problem. So when I draw my number line, I'm looking for the distance from -5 this time.
Yeah.
And I need that distance to be 6. So that means I can be 6 units this way. You said it's a solid dot. What number is 6 units this way? 1, +1. And what number is 6 units this way? -11. Okay, now wait, look what I did. I put -5 right here in the middle. and I counted forward 6, and I counted backward 6. Now those are solid dots this time because there's an or equal to, you remember that. These were open dots because this one was not or equal to. Now, I'm either going to shade outside the dots like I did this time, or I'm going to shade in between the dots. Now think about what it says. It says the distance is less than 6. That means you have to be closer, right? And if you have to be closer than 6, don't you have to be in here?
Yep.
So my answer is all of the numbers between -11 and 1. Oh my gosh. Look at the way I wrote my answer. What do we call that?
Oh, interval notation.
Interval notation. Now, I didn't have to write it that way. I could have written it this way. That's perfectly okay too. Either one of those is fine.
Is that only if it's less than or equal to?
No, you can use, I didn't use interval here because this one I'd have to use the infinities, and it's not quite as handy. This is real handy. It's real simple to write that as an interval, but you can always write it as an interval. Okay, all right. Before I erase these, what I'm doing is so simple. In the middle of the number line, I put a 2, and then I counted back and forth 3. So 2 plus 3, 2 minus 3, right? I put dots there, and then since it was greater than, I shaded out. So this one, I did have to be, this is a little tricky, this had to be a minus, so it's minus a negative, so I put a negative here in the middle. Some kids think about it like this. Whatever's in here, put the opposite on your number line. So if it's x minus 2, I put a 2. If it's x plus 5, I put a -5, right in the middle. And then I count back and forth this many. So forward 6, backward 6. Close dots, because they are equal to. And then my choices are, I shade out or in. This time it was in because it was a less than, littler numbers, closer numbers. All right, so let's look at the next one. What's a little bit unusual about the next one? There's a 2x. Any idea what we might do with the 2?
Divide it.
Divide everything by 2. Now, kids might say, Miss Ford, you're allowed to do that. Remember, Mrs. Ford does not break rules. All right, so if I'm doing it, you're allowed to do it. You're allowed to divide by 2. So we have x minus 4 greater than or equal to 7 halves or 3 1/2. Doesn't matter to me. 7 halves, 3 1/2, 3.5. So I'm going to draw my number line. In the middle, smack dab in the middle of that number line goes the opposite of this number. So this is x minus 4, so I'm going to put a 4. Now I'm going to count this way and this way that much. So 4 plus 3 1/2 would be 7 1/2. And I'll put a solid dot there. 4 minus 3 1/2, 0.5, solid dot. And then your answer will always be either in between those 2 dots or outside those dots. This is a greater than. Greater than means outside, getting big. So my answer is everything less than or equal to 1/2, or everything greater than or equal to 7 1/2. instructions don't say it doesn't matter. You do have to write an answer though. Your picture, if you do it this way, you'll have a number line as your, I mean, this is how we get our answer. We draw on the number line. That can't be your answer. You have to actually write something down. And I wish I hadn't erased this. Back in the beginning when we were talking about this, we said the reason we take absolute value is because we can subtract in either order. If I have 3 and 5 on the number line and I want to know how far apart they are, can I do 5 minus 3? Yep. Can I do 3 minus 5? Yep. Aren't these exactly the same thing as long as I'm in absolute value?
Yes.
So when I look at this next problem, I don't know about you, this bothers me. I think it's backwards. But you know what? Since it's in absolute value, I can turn it around. If I don't like subtracting 5 minus 3, I can subtract 3 minus 5. If I don't like it in this order, I can make it in this order. Now, you can't do that unless you're in absolute value. But as long as you're in absolute value, subtraction can be switched around. So I don't like the way this looks. It bothers me. I'm not going to be able to do my problem in this order. So I'm going to switch it around. It's the same thing. Now, what's wrong with it? It's got this dumb 4 here. So what am I going to do? Divide everything by 4. So x minus 3/4 is less than 9/4.
Yep.
I'm going to go ahead and leave the fractions this time, because right in the middle of my number line, I'm going to put a 3/4. And then remember what you do. You count forwards and backwards 9/4. So it's nice having a common denominator. If I have 3/4 and I add 9/4,
12/4.
that would be 12/4, which is 3.
Yep.
If I have 3/4 and I subtract 9/4, negative 6/4,
Yeah.
which is negative 1.5, negative 3/2. So right here, right in the middle of my number line, I put the opposite of that number. I put 3/4. Then I'm going to count forward that many and backward that many. So the opposite of this goes in the middle of your number line. Then you add and subtract that. So 3/4 plus 9/4 is 12/4. 3/4 minus 9/4 is negative 6/4. Now I put open dots on those two numbers. Was that appropriate?
Yep.
Yep. And now I'm going to shade either outside the dots or in between the dots. It's a less than, so it's going to be shaded in between. And my answer is negative 3/2 to 3. And I'm using the parentheses because those are open dots.
Can you do a problem that doesn't have absolute values? Because like these, they do, but since you said you couldn't switch the signs if there weren't.
Well, if you had a problem, if you were just solving this, if it was not absolute value, that's just a regular equation. You're just going to subtract 3 from both sides, and then divide by -4 and switch the sign.
Oh.
Okay?
Yeah,
Yeah, that's just a regular problem.
So you can't just divide by -4 at the start?
No, because it's inside absolute value, so it's not really -4.
Okay.
See, it would be -4 on one side, but it'd be positive
So if it
4
has-
when it takes out of the
You can
absolute
only divide
value.
if it's positive?
Positive, yeah.
Okay.
Yep. His absolute value will change the sign.
Yeah, I get it.
If it's not positive.
I tried doing that at first, then I got completely.
Yep, you would, because it's wrong. Illegal, good point, but it's illegal. All right, well, we've covered a lot today. We got a couple more things to look at. I want to do one more of these, so I don't know if you got room in your notes just to squeeze it in somewhere. But I want you to try one using this method without my help. Just see if you can figure this out. We'll make it pretty easy.
We're just doing it.
Just do it somewhere over to the side. Or on another sheet of paper. See if you can solve this one using this strategy. Or yeah, on the desk, if you want to do it on the desk. With a marker and a rag. So remember, with this strategy, we use a number line.
Yep.
And you always start by plopping something right in the middle of the number line. Where does the something come from? Where do you get the something to plop in the middle of the number line? It is the opposite of this, right? So hopefully you all have plopped a -3 in the middle of the number line. There is no dot there. Don't put a dot there. The dots go out here. This is where the dots go. How do you figure out where to put the dots?
Add 5.
You add 5 and subtract 5. So in the middle of the number line, you plop the opposite of this number. And then you simply add and subtract that amount. So, should these dots be open or closed?
Closed.
Am I going to shade between the dots or outside the dots?
Between.
So hopefully, you either wrote as your answer this interval or this inequality. Alright, one more. And this time I'm not going to say a thing. I just want to know what the answer is when you're done. I'm not going to say a word. I want you to do this one.
Is there a reason you put X instead of equal 3? Final answer.
Because it's an inequality.
Okay.
Yeah, there's always an X there.
Okay.
All right, do this one. Tell me what the answer is. Remember, you're plopping something in the middle of the number line and you're counting back and forth a certain amount. Anybody have an answer?
-2 and 6.
I need like inequalities, so like X.
6 is greater than
6 is greater than X. Yeah.
So what is it?
6 is greater than X.
No, start with -2. -2 is less than
Less than X.
which is greater than 6.
Okay, let's talk about this for a minute. Did you divide everything by 2?
Yeah.
So you had X minus 2 is greater than 4?
Yeah.
So in the middle of your number line, you put a 2,
Yeah.
no dot, just
No.
a 2. And then you counted 4 this way, and that's how you got the 6.
Yeah.
And you counted 4 this way, and that's how you got the -2.
Yeah.
And then you looked at this symbol and said those are open dots. And then you said I'm greater than, so I'm shading out here. Alright, so is that what your picture looked like?
Yeah.
So our issue is we don't know how to write that as an inequality. Boys and girls, how many shaded regions are there on the number line? 2. This one had 1. So when I wrote my answer, I wrote it as one piece. When you have 2 pieces to the number line shaded, you must have a 2-piece answer. So you are either going to say X is less than -2 or X is greater than 6. Don't put those together. If you put them together, it's wrong. If you put them together, you're trying to give me a 1-piece answer for a 2-piece picture. Or you can say negative infinity to negative 2 in union with 6 to positive infinity. So this would be the interval way to do it. This would be the inequality way. If the directions don't say, it doesn't matter to me which way you do it. All right? Okay, it says 8:48. Why do we have our backpacks on? Why are we all packed up, ready to go? Guys, no, every minute of math counts. Don't be disrespectful. In your mind, you can think, I can't wait to get out of here. But don't act that way, it hurts my feelings. Less than negative 2 or greater than 6. That's the way we're going to write our answer. Okay? Now we're going to do one more problem. We're going to do one.
That's always it's great.
Okay, so when you make the, so for that problem, you would make it x minus negative 3. And then they do negative 3, but on that one, it's x minus 2.
Yes, we put it at the opposite of what's in here. So if that's x plus 3, we end up putting it at negative 3. If this is x minus 2, we end up putting it at positive 2. Whatever would make this 0, that's where you put the number. So 2 minus 2, I'm putting it at 2. Negative 3 plus 3, I'm putting it at negative 3. All right, one more problem. You made me mad, so now we're going to do one more. X squared minus 4x minus 5 is greater than 0. This is not absolute value. We are switching different kind of problem. When you see this, forget that. When you see this, what automatically pops into your head? Factor. So I'm going to factor this guy. Now, I'm going to put 2 dots on the number line. Take a wild guess where those dots are going.
Negative 5 and 1.
At what? Negative 1 and 5. Perfect. Just like with the absolute value, we started with the opposite of what was in there. We're going to put dots at the opposite here. So we're going to put a dot at 5 and a dot at negative 1. Now, they have to be in order. Make sure they're in order on the number line. Should they be open dots, do you think, or closed dots? Open. Because it's no equal to's. And now I'm going to shade, just like I did before. Take a wild guess. I am going to shade outside. Why am I shading outside? Because it's greater than. So, you can leave as soon as we get the answer written. This is a 2-part answer.
Negative 1.
X is less than negative 1, or X is greater than 5. Rush out! Whoa! Don't hit anyone. Make sure that you erase the desk with a rag, put the rags and markers away. I will see you tomorrow.
I'm going to be, I've got a coming down.